This is the session about how to define a storage infrastructure for AI and analytical workload. My name is Jason Wu. I'm the Director of Product Management for Google Cloud Storage. Joining me today, we have Dave Stiver from Google Cloud. We're also very excited to have Yusuke Yachide and Alex Bain from inference by Toyota joining us on stage as well. So this is today's agenda. First, we'll give a quick overview about AI workload and its challenge presented for storage infrastructure. Next, we'll share the cloud AI storage vision and the products we have, particularly around some of the new product and capability we're announcing during next. And then we'll have inference by Toyota to come on stage to share with us how they are leveraging cloud AI storage on Google Cloud. And the last, we'll leave some time for Q&A at the end. So cloud storage, also known as GCS, has been providing the highly scalable, secure, and reliable storage for data-intensive workload for the last decade. AI has been a key workload for cloud storage in the past. It's not anything new. However, in the last couple of years, with the emergence of Gen AI and the large language model, which presents some of the additional unique requirements and challenges for storage. AI fundamentally is a very data-intensive workload, and the storage is a critical component for running the end-to-end AI data pipeline. Here, I show a typical AI data pipeline from the data ingestion, and then the data will get validated and pre-processed before they can be ready for AI training, model training. After model training and the model validation, the model can be available for inferencing and serving to the end users. Usually, this is an iterative process. Customer oftentimes takes the feedback from the model inferencing and pump that feedback to data preparation and model training as well to have this continuous improvement over the data pipeline and the model. And of course, after model is getting ready to serving end users, a lot of the content need to be served and delivered to end user, and a lot of those content need to be stored on GCS as well. There are three major phases of AI data pipeline, which present some unique challenges for cloud infrastructure, for storage infrastructure. The first one is data preparation. This is the pipeline to pre-process the data to make it ready for training. Oftentimes, customers want to get better data, get better model accuracy, which requires customers to increase the data window, which often leads to larger data set and more data storage and consumptions. There's also this model freshness. In order to get the best model freshness, you want your storage system to provide the best throughput to you so that you can get to your model quickly. As for model training, the biggest challenge for storage system is how to keep the expensive and hard to get GPUs and the TPUs busy working all the time. Right? So this means that how can we minimize the training data load time, as well as how can we accelerate the checkpointing to the storage system, as well as restore from the storage system in the case of node failures. And the last major phase is about inferencing. The goal is that to accomplish this fast startup time, which can minimize the model load time, especially important given the size of the model could be very large as the model gets bigger. So to summarize, there are four categories of requirement for AI workload. The first requirement for storage infrastructure is around performance and scalability. We need the storage system to be able to support exabytes of data scale. And we want the storage system to provide high throughput. Not only high throughput in aggregation, in terms of tens of terabits throughput from the storage system, but also the throughput from storage to the individual compute node you have. The second major category is data management. We want to have a single source of truth, which can be the common data repository for all of the AI phases and workload you have. And granted, you may want to use different storage solutions which are optimized for different phases of the AI workload. But at the end, we want these different storage solutions to be seamlessly integrated so that you don't worry about copying data around, moving data around, managing different versions of the data everywhere and all that. The third one is also very critical, is that data governance. As you can see, these models are highly data intensive and compute intensive. They're very, very expensive to train, and they're super valuable once they are trained. So you want to secure your model with the right access control, with the right governance, and you also want to have the ability to figure out what are the data lineage of the model, what are the data sources being used by model training. Last but not the least is the ecosystem support. Whatever storage infrastructure you have, you want that to be integrated with the common frameworks you are using, integrated with the common ML platforms you are using, as well as it's integrated with the compute infrastructure you are using. So we took this opportunity to rethink, to really fundamentally rethink what the storage infrastructure should be for the AI workload. We come up with the vision for cloud AI storage and the product for that particular vision. So to summarize, the vision is that we want to have the ability to store the data once, and then that data can be accessed from anywhere with any performance, with any interface of your choice, and at any scale. So I know there's a lot of words here, and let me unpack it and explain a little bit. Right? Store data once means that you can store data to a single destination where you can maintain a single source of truth. This not only dramatically simplifies the data management and the data source, it also can help you cut down storage cost dramatically, because now you don't have to maintain multiple copies of the data in different places and all that. So you only need to write once and store it once, and the data is always available to you as a single source of truth. Access anywhere means that we provide the ability for you to access to that data from any region, any zone of your choice. Right? With any performance is that we know that performance is critical for AI workload, whether it's a high throughput or whether it's low latency. We provide different storage solutions that allows you to access those data with that kind of performance characteristics. With any interface means that you have the choice of accessing that data either with the object interface or with file interface, whatever you prefer and whatever you need to use with your framework and application. And at any scale, we want to be able to support the workload, whether you have gigabytes of data you are working with or whether you have exabytes of data you are working with. The storage system can scale with you. So to put it all together, cloud AI storage is a place to land all of your data. It's optimized for both AI training as well as for AI serving. And it's integrated with the ML ecosystem. Right? Underneath the cover, within the cloud AI storage, we use GCS, the object store, as a single data repository. So you can write all of your data to GCS. That becomes your single source of truth. On top of that, we provide a portfolio of high-performance optimized storage options for you to use for specific goals and specific phases of AI training. For example, we just announced the GCS Fuse with cache support during next event a couple of days ago. So this GCS Fuse provides file-like access to all of your objects stored in GCS. Now we added the support for local caching so that you can get the caching and the performance acceleration when you access those data. In addition, we provide 2 additional full-fledged distributed file services on top of GCS, File Store and Parallel Store. Both of them provide high performance as well as the POSIX compliant if you require the file API to access your data. We also just announced the hyperdisk for ML, which allows you to cache some of the data from GCS and which can be read and used by many compute nodes at the same time. That can dramatically cut down your serving latency and your startup time. We continue to improve local SSD to make it better for AI workload. And today, we also just announced in the previous sessions, Samit and Nathan also just announced the Anywhere Cache support, which is a high-performance object caching sitting on top of GCS, allows you to go anywhere in a continent and bring your data closer to your compute, closer to your accelerators. This is fully integrated with GCS, offers a seamless integration. So from the application point of view, it's completely transparent. You don't need to change anything in your application. Once you turn this on, you get the performance acceleration you need. So this is a very exciting list of features. And I will hand it over to Dave, who will get into some more details about each of these products and how they can best leverage for different AI phases. Dave?
Thanks for the overview, Jason. So my daytime job is looking after different parts of GCS, but my nighttime job is actually looking at AI/ML workloads, specifically across file, object, and block. So today is great because I get to introduce you to 5 new products that were all specifically designed to accelerate AI/ML workloads. So to put them into context, we'll use the AI data pipeline and talk through the different stages that Jason introduced. Data preparation, then we'll spend some time on training and checkpoints, then we'll move on to inference, and then we'll look at how you can bring the whole thing together with a use case. So data preparation, we talked a little bit about the importance of that, and our customers who have continuous pipelines of data that they want to train and tune their models with. And if you think about it from a customer perspective, there are 2 aspects of the models that you care about. How fresh is it? So how often can I tune this model with my latest data, right? Which is really a function of storage throughput. How quickly can I process this raw data and turn it into something that I can train with? And then model accuracy, which is really a function of the window of data. So am I training with a day's worth of data, or 7 days worth of data, or a month worth of data, or even a year's worth of data? So that really goes to the scale. And that's where Anywhere Cache becomes an amazing product in this case. So Anywhere Cache is a local SSD-based zonal cache that's built directly on top of cloud storage. And what's amazing about it is it's an on-demand product, and it allows you to scale your throughput and your storage footprint. So the initial release of Anywhere Cache can have up to 1 petabyte of data in a single zone cache. So you're bringing that data out of a regional bucket and bringing it close to your storage, to your compute workload. And it also can scale up to 10 terabits of bandwidth in that single cache. And so throughput here is really a critical part of the storage workload, particularly for AI/ML. So as a typical example case, you may have models deployed in an application. You're constantly pulling raw data from that application and dumping it into cloud storage regional bucket, maybe with data flow. And then you're getting ready to transform that raw data into something that you can actually train against. And so you lift that data up out of a regional bucket into a local cache that's there in the zone directly next to your data proc cluster, and you're able to accelerate that data preparation process. Another really exciting use case for Anywhere Cache is delivering on that view of the vision where you can store your data one time and then use it anywhere. And I'll just point out, this is it's a journey that we're going on, and we want to deliver on that mission, but Anywhere Cache is incredible in this case. we've seen in the last couple of days there will be a continuous stream of innovations in accelerators. Whether you're using GPUs or TPUs, the next generation of that accelerator hardware is always just a month or a week away. And so we have very large customers that want to always be training on the latest generation of hardware. As we deploy those large instances or large footprints of the hardware, they're often in different regions. And so you might have to go from one region to the next as you train your models. The before anywhere cache, you would have to replicate that training data from region to region. But the mode that we want to be able to share with you is to store your data one time in a multi-region bucket, and then wherever you need to do your training, you're able to use anywhere cache essentially to promote your training data, not just into the region, but directly into the same zone wherever your accelerators are. So we're really excited about this, especially if you're moving just to the next generation and the next generation. Okay, let's talk a little bit about training. We've been saying specifically, right, we have these precious, very precious GPUs and TPUs hardware, and the whole point of this is to keep them hydrated. And so the thing you want to avoid are storage I/O bottlenecks. So two products. The first product that we want to talk through is Cloud Storage Fuse and the local cache. So probably many of you are familiar with Cloud Storage Fuse. It's a way to essentially mount your bucket as a local file system. And so you get access to your GCS objects through a file API, which is the way most of the industry wants to consume their storage. The thing that we just announced in the last month was the GA support for this local caching capability. So now you can use the local SSD that's there on your GPU instances. I think the A3 version of the hardware has up to 9 terabits of local SSD associated with it. So now you can keep your data in GCS and then cache it locally directly onto the VM that has your accelerators. So we've been doing a lot of benchmarking. If you look at this chart on the right, it's a comparison of just training time. The FS spec is sort of our baseline case. If you're not familiar with that, you can think of that as the standard way that Python would interface to GCS. And so the horizontal axis here is just training time. So the shorter, the better. So each of the different colors is a separate epoch in your training job. So you see the lightest color is the first epoch. And so between the two cases, the baseline and the acceleration version with GCS Fuse, it's about the same time. But each epoch after that, you see it takes like a third of the time. So if you're doing 10, 12, 20 epochs at a time, if you're tuning that model, you see you get that benefit. In this particular benchmark, we see 2.2x improvement in training time. And this leads to 60% savings in overall TCO. And that's aggregate TCO looking at both your compute and your storage cost. Another product that we just GA'd in the last month is an accelerated data loader for PyTorch, specifically on object storage. That product is really tuned to focus on early model development. And there again, we see a 3.5x improvement in training time, which leads to a 70% improvement in overall TCO. So I want to point out these two products are just acceleration that we put on top of cloud storage. So there's no additional cost, storage cost in any of these. They're just delivering savings and improved performance for your overall workload. But there may be cases where you need more performance storage. And so we have two additional products that we're really excited to talk about. The first is Parallel Store, which is in private preview already today. This is Google's first parallel file system. It's built on Intel's Deos technology, if you're familiar. It is directly integrated with GCS as well. And in this similar benchmark, we see a improvement in the training time of 3.9x. So a huge, huge improvement there. And if you look carefully, you'll see because this is a separate file system, we're able to push that data from cloud storage into Parallel Store before you start the training job. So every epoch, even if you're just doing a few epochs, you get that benefit of the improved performance. But it may be that you don't want to use file, or you want to bring your own file to us. And so you don't have to choose Parallel Store. We also have the hyperdisk capability, which is block storage that's been optimized specifically for AI workloads. It is also integrated directly on top of cloud storage. And in that case, we see 3.2x faster training times. So the integration with cloud storage and that repository is really a key part of this. You can easily push data back and forth between the different storage solutions. And so training data you may pull from cloud storage and promote essentially into parallel store. And then checkpoints, if you're writing checkpoints and those are very important to you, you can take the durable checkpoints that you need to store your models long term and push them down into GCS for long term. Okay, and lastly, let's talk a little bit about inference. Most of our focus has been on large language models. It's very clear that all of us are going to be using some form of LLM in our business needs. And it's very clear what's happening with LLMs. They're just getting more and more capable. And as we grow with the number of parameters that those models have, the physical size of the model is actually getting bigger and bigger. So it's super important that we're able to maintain very low load times from physical storage up into the computer accelerated hardware that you're using to actually do inference on. So this is a wonderful case, like tailor-made for HTML, because it allows you to scale your throughput independent from your storage. It's tailor-made for this particular use case. And in our benchmark, again, with a baseline case versus HTML, we see improvement times of 3.7x. This is probably best for what we see is for very large models. So if you're dealing with a model size that's maybe 20 gigabytes or larger, HTML is the best way to accelerate that workload. But you'll probably have a range of models. Not everything will be a very large model. So we just wanted to point out we've been doing this benchmarking, and even just using Cloud Storage Fuse directly on top of GCS, you can get a 3.3x improvement over the baseline case. So larger than 20 gigabytes, use HTML. Smaller than 20 gigabytes, please use Cloud Storage Fuse. So let's put the whole thing together sort of in an end-to-end use case. And we've been spending a lot of time with the healthcare industry thinking about the data they use. So in this case, think of it as a pathology use case with medical imagery. And we're going to go through the whole model development cycle. So imagine you got an ML scientist that's got a small amount of data. They're looking to build this model and understand this sort of pathology and introduce it. So maybe they're doing 1 or 2 epochs at a time, trying to build that model out and get it to a place where they can release it into production. We think the accelerated data loader is just a really good, simple way for them to get the 3.2x improvement in training time. But now let's say she's done developing that model and she's ready to put it into production. But they don't just want a static model, right? She hands it off to an ML engineer who's going to take that model and then tune it continuously as new data becomes available. So that ML engineer could choose Cloud Storage Fuse and get the benefits of all those successive epochs, right? Maybe they're doing 10 or 20 epochs at a time. And with Cloud Storage Fuse, they'll get that 2.3x improvement. So great, we're in production. That model is now being tuned maybe on a monthly basis. But now they want to bring even more data into that model and make it an even more performant model. And so maybe they grow out of their data set. Maybe they're just a few terabytes that fit on a single node for training, but now they need to expand that to something larger. That's where the scalability of parallel store really comes into play, up to 100 terabytes in a single training data set. So they graduate essentially to parallel store as sort of a scaled up production use case. So that's sort of the end-to-end journey through a whole model lifecycle. That's the way all of these 5 different storage products can be used to accelerate, regardless of what stage you're working with. I think now I'd like to hand it off to Yachide and Alex to tell us how Toyota is using GCP and GCS.
Thank you, Jason and Dave. Hello, I'm Yusuke. Please call me Yachide. Today, I'm going to show you our platform titled How Even by Toyota runs large-scale ML workloads for the automated driving. We established our company as a Toyota Research Institute Advanced Development in 2018, now as Even by Toyota. We have been contributing a lot of the business in Toyota Group under the vision of mobility to love, safety to live. So, as some of you may know, that Toyota has lots of the company, teams, and alliance. For example, here we have ADAS for the automated driving and multimedia for the cockpit experience and so on. Of course, there is a team that developed the test course for mobility, like the Urban City. So we believe that it is so important for the developer of the application to be able to focus on application development. For that reason, we have to provide stable and ready-to-use platform for them. On the other hand, we strongly believe that domain shouldn't be not too close within the domain, but the data or machine learning model should be shareable appropriately. The enterprise AI platform in Urban is built to be the platform to support the various domains of the requirement, providing the best platform not only in terms of the cost, but also ensuring the sufficient GPU. Our strategy to achieve that is multi-cloud technology. By having a multi-cloud technology as a strategy, our goal is to integrate any of the services from the cloud vendor into our services. So here is our platform of the diagram of our platform. So we provide so the first thing first, user has just join our platform, just jump in the platform to specify the data or machine learning training code. So we provide a match pathway to support the various requirements of the multi-domain, as I said. Application layer makes machine learning workload job which enable running it any path user specify. So what that means, in this case, for example, so one is the low abstraction layer, like a Kubernetes. Another is managed services. In case of the Google, the Vertex AI. The final step is to execute the machine learning job on a given platform. We have built such a mechanism with another vendor before in the past, but we have recently succeeded integrate the GCP-based platform under our multi-cloud technology. To achieve that, we face several challenges, but especially the file access, especially the cost and the speed, performance. So to achieve that, so we had a lot of the things we did. So in the following page, I'll explain from our team. We'll explain that how GCP, especially GCS, can be utilized for the challenges and provide the value to the user. Now, let me hand over to the Alex. Thank you.
Thank you to my boss, Yachide-san. I'm Alex. And I'd like to start by discussing the first iteration of our cloud training architecture based on our previous cloud vendor. So let's work from the bottom to the top. So Woven by Toyota keeps its machine learning training data sets in cloud object storage, probably like most of you do. It's the best place it's a cost-effective and highly reliable place to keep our data, but it's also where we implement our best practices for data governance. So we have, for example, our data retention policy, secure access policies, and the way that we separate our data to meet our legal and privacy constraints. But we do not actually, our training jobs do not actually access cloud storage directly. Instead, we use our cloud vendor's Lustre service. So if you don't know what it is, Lustre, it's an open source parallel file system designed for super high performance, for low latency and high throughput access. And the way it works is when you create a Lustre drive, you can create an empty drive and copy your data there from Cloud Object Storage. Or you can designate that parts of your Cloud Object Storage buckets will be synchronized into your Lustre system. Then when we run training, Woven runs large-scale Kubernetes clusters in the cloud on GPU instances in which we run distributed training jobs for things like ADAS, large language models, and other machine learning training jobs that we have across the company. And the way that we actually access that data is we can mount the Lustre file system as a local volume into all of these training nodes. So the files, they just show up and they kind of look like local files. Of course, if we're actually reading them during the course of the training job, what's happening is the contents of those files are being streamed in from the file system in real time across the network. So this was our first architecture, and it's something that works. It's not unique to Woven by Toyota. A lot of companies have this architecture, and you might as well. And our users began to bring their data. At first, they were hundreds of gigabytes, and now they're often terabytes. And so things are working, but over time, we realized there's actually some issues with this solution. So the first of all is that you are paying for the performance of that Lustre infrastructure. It's not cheap, and actually, of course, the GPU cloud instances are what we spend most of that's the largest thing that we spend money on. But over time, we actually spend something like 40% of the overall cost of the platform just on the Lustre infrastructure that we're using to serve those training jobs. And that's crazy, right? Like, we should be spending the money on the actual training and not this thing that we're using for the data access. The second thing that happened is that at the beginning, we set up 3 Lustre drives. And how many you want to have is basically sort of like up to you, right? Some companies, they just have a single big instance. Although it's a little bit more common to have multiple instances for a few different use cases. So we started with 3, and users began to bring their data. And now we have something like more like 30. It kind of reminds me, like a couple years ago, my spouse convinced me to get a kitten. Then it seemed lonely, right? So maybe like after 6 months, we got another one. And this past weekend, before I came to Vegas, we got our third cat. So like it's kind of like spiraling out of control. And I feel the same about what was happening with our storage infrastructure. So in addition, that's 30 places addition where we have more copies of our machine learning data sets. So now all of these data governance policies, we have 30 new places to keep our data in compliance with that. So we realized the situation was untenable, and we started trying to find out what can be a long-term solution and have a new architecture to solve this cost and data management problem. Oops. So at the same time, we want to increase our GPU availability by going multi-cloud. So we began to expand into GCP, and we were talking with the Google team, and they encouraged us to try a new storage option, Cloud Storage Fuse. What we did is we ran a bunch of our machine learning training experiments where we copied some of our most important data sets into Google Cloud Storage, and we ran a series of training jobs with Cloud Storage Fuse. So what you do is, if you're running in GKE in a Kubernetes cluster like we are, you install a CSI driver into your cluster. If you're just using VMs, it's a kernel driver that kernel module that you install into your VMs. And then just like Lustre, you can mount the data directly from cloud storage into your jobs and access the files that they look like local files. Of course, what's happening is if you touch the files, they're actually being streamed in over the network into that file system. And the incredible thing is that we're not running this Lustre service, right? We're just using cloud storage. But the performance we're getting is actually kind of Lustre-like for our needs at Toyota. So right there, we realize that's the 40% that we can save, Toyota can save on its training budget. That's huge. That's serious money for Toyota. In addition, those 30 additional copies of the data that were living in our Lustre service are gone. In our machine learning training jobs, kind of on the right, the yellow represents a training time. And we have one particular job that actually ran a little bit faster in cloud storage than it did with the previous version based on the Lustre service. Some of the jobs ran about the same, some ran a touch slower. But our point being is that Cloud Storage Fuse basically worked out of the box for most of our jobs, and we saw comparable performance. Now, I did notice that Parallel Store was announced this weekend, so now there is actually a Lustre-like service available in Google Cloud. And if you have a much larger scale, then perhaps that's an option for you. But for us, we can see that Cloud Storage Fuse is working for us and meeting our needs. So we weren't quite done there yet. The Google team asked us to try one other thing that they had in preview, which is the Cloud Storage Fuse cache. So what happened is that the experiments that we were running, we didn't write them. We wanted to pull real experiments from users. So what they did is the user code, it actually just, whenever you have to access files, it just accesses them from cloud storage, right? So we run rounds of training called epochs, and in each epoch, we're touching the data. And you can look at the top graph, the pattern of read accesses to the data basically looks the same in every epoch of training. They're touching the data, and when users needed it again, they just go ahead and get that file again from the network. And you might think to yourself, well, wouldn't a smarter thing to do is in the first epoch of training is just cache that data in the local SSD that you have on the node, then you don't have to reach out and touch it in the network again. And as a systems engineer, my response to that has always been like, well, I wish I could just have like a library or a system service that would do that for me, right? So I don't really want my users who's like a computer vision person trying to write this cache code. But Fuse Storage Cache is exactly that option. And it was preview for us, but I think it's gone GA now. And all you have to do is basically turn it on and configure it a bit. So what happens in the second epoch of training in the bottom chart is the read count for cloud storage has gone to 0, right? Because we already touched all the files, and they're already cached in the local node. In the training time reduction, in the 33% faster, what that means is that this was time in the model where basically the GPU was stalled before, waiting for network access for the data to be pulled from our cloud storage or similarly from our Lustre service before. So when we turned on Fuse, that stalling was eliminated and the training time is accelerated for 33% faster training. So that's what I wanted to tell you about our experiments with Cloud Storage Fuse. Looking forward to using it, and I'd like to invite the Google team to come back and wrap up our presentation.
Thank you, Alex. Fantastic story. Thank you so much for sharing your experience with everyone. So what I want to say is that if you want to experience the same cloud AI storage Toyota has been able to experience, if you want to get to the same performance and with the significant saving Toyota has realized, come to Google Cloud to check us out. Cloud AI storage today is not only available to Toyota, it actually has been powering a lot of the AI transformations across industries. So I'm not going to go through all of the list of the customers who have been using and benefiting from the cloud AI storage today, but I encourage you to go and take a look at it and give it a try. We also have a QR code you can scan if you want to get connected with our product team or our provide some of the feedback to our research team. We would love to hear from you. So scan that QR code and get connected with us.